Hi, welcome back to another episode of Algebra in Words. In one of the last episodes, we went over greatest common factor and least common denominator, more of an overview. But what I have on the board now are a few examples. Before we do the examples, I just want to remind you one of the reasons and importances of greatest common factor. From here on out, you always want to start off a problem. These are expressions, but ultimately you'll get to equations. It doesn't matter. Either way, one of the first steps that you want to do is to look for a greatest common factor, and if you can find it, factor it out in front and put what remains in parentheses. So that's what we're going to get a little practice doing today. I have some 5 problems that are going to be a little bit progressively more difficult as we go, and it's ultimately going to lead to a bigger point, which is going to connect to other topics, which I'll explain at the end. So first, let's look at the top one. It's a binomial, 3a squared plus 3a. Alright, and all you have to do is analyze each term and ask yourself, is there, and if so, what is the greatest common factor? So if we look at the top one, what factors do each term have in common? It's good to analyze from left to right each individual factor by itself. And what I mean is, start off by analyzing the coefficients. They're both 3, so it's clear that in this case they have a common factor of 3. So for now, I'm going to write the common factor of 3. Then let's go to the next variable, the a's. This is a squared, this is a to the unwritten 1. They both have a common factor of a to the 1. So I'm going to write the a next to the 3. And remember, if you remember from the last video, you find greatest common factor by the common factors, and if they have common factors, you choose the shortest or the smallest exponent. The smallest exponent of the 2 and the 1 is obviously the unwritten 1. That's why we chose a and not a squared. So I'm going to write parentheses, and what we're going to do is, remember, greatest common factor is also a greatest common divisor. Think of dividing each term by the greatest common factor, and whatever's left goes in the parentheses in sequential order. 3a squared divided by 3a is going to give you a. And 3a divided by itself, 3a, this divided by this, is 1. Keep the sign, close the parentheses, and that's the end of that problem. Let's look at the next one. Also a binomial, but now there are a few more factors than in the previous problem. Again, let's start just strictly by the coefficients. There's 2 and 2. They happen to be the same coefficient, so we're going to add that to our greatest common factor. And then we're going to move on to the next variable, looking at the pi and the pi. They both have pi to the 1, so we're going to write pi. We don't have to write the exponent 1. Then let's go to the r's. This has r to the unwritten 1. This has r squared. Choose the smaller of the exponents, just this r. And then there's no factors left here, but actually there's still an h here, but there's no h here. So since there is an h here but not here, it's not a common factor, so we're not going to add it to the greatest common factor, and so we're done. Now we'll write the parentheses, and we're going to divide out the greatest common factor from each term, starting on the left. When we divide 2 pi rh by 2 pi r, we're left with h. Add the plus sign, and then 2 pi r squared divided by 2 pi r leaves you with just r. And that's the end of that problem. Close the parentheses. A quick note that, as I did promise in the last video too, we will in a later video go to specific how to multiply and divide common bases with exponents. So in other words, to find out how we got r squared divided by this r to get that r, I go over that in a later video. But for now, I just want to do the problem. Let's go to the next one. There's 3 terms. It looks like there's a little bit more going on here. We have 14x squared y minus 35xy minus 63x. Alright? So again, go from look at each start with the term on the left and go factor by factor, starting with the coefficient. This is 14 compared to 35 compared to 63. Do they have a common factor, a common number? The answer would be 7 so far. So I'm going to write 7, and if we do 14 divided by, well, we'll do that part next. Let's go to the x's. X squared, x, and x. They have a common factor of x. So I'll write x with our greatest common factor. Then let's go to this factor, y. This has y, this has y, this has no y. So since this term has no y, even though these both do, there's no common factor of y among the three terms, so we leave that out from the greatest common factor. Draw the opening parentheses, and now think of 7x divided by 14x squared y. Okay, 14 divided by 7 is 2, x squared divided by x is x, and y divided by just 1 is y. Keep the sign. 35 divided by 7 is 5. X over x is 1, so we don't write anything because we don't write 1. We could write it. And y divided by 1, or no factor of y, will stay y. Write the sign. And now 63 divided by 7 is 9. X over x is 1, so we don't write anything for that. And there's no more factors. So we'll close the parentheses, and that's the end of that problem. Let's go to the next one down. The next one down now has 4 terms, and also there's a few variables involved. Okay, so let's look at the coefficients first. 3, 2, 5, and 2. Do any of those numbers have a common factor? No, they don't. So then let's move to the x's. This has x, this has no x, this has x, and this has no x as well. So there's no x's in common among those 4 terms. Then let's look at the y's. Y squared, y, and y. That is a common factor. It's the only common factor of those factors, and it happens to be the greatest common factor. So we write the y, write the parentheses, and let's try to squeeze in on the board space the factors that remain when we divide y out of each term from left to right. 3x y squared divided by y is 3xy. Keep the next sign, which is minus. 2ay divided by y is going to be 2a. Keep the sign. 5xy divided by y is 5x. And negative 2y divided by y is negative 2, minus 2. And close the parentheses. And that's the end of that problem. That brings us to the last problem for this video. 5x times the group x minus 7 plus 3 times the group x minus 7. I put this on the board for a reason. All of the problems that we've done so far are to lead us to a problem like this. Now, in the previous 4 problems, the greatest common factor was made up of a monomial, or one term. But a factor can be a group that's made of more than one term, all right? And basically, another way to say it is a group can also be a greatest common factor because a group can be a factor. So even though this greatest common factor and this one and this one and the y look alike in the sense that they're one term, let's look at this problem. Okay, if you sometimes I tell my students sometimes to just stare at it for a second. What stands out at you? Well, if you look at this for a second, you should notice that the group x minus 7 and the group x minus 7 is alike. It's common among this is a term and this is a term because they're split apart by the plus. This is a group, it's also a factor. This is a group, it's also a factor. It's the greatest common factor. So we're going to factor that out just like we did any other factor in the problems before. So, like in any other problem before, we start off by writing the greatest common factor first, then open a new set of parentheses, and then we're going to write the factors that remain in that group. Now remember, this is the GCF, and the way that you find the remaining numbers is to divide each term by the greatest common factor, and whatever's left goes in this set of parentheses. So if we think of dividing this by what we determined as our greatest common factor, the group x minus 7, this whole group cancels itself out to 1 because it's itself over 1, because it's itself over itself. That leaves you with 5x, and 5x goes in the parentheses first. That brings us to this term. Once again, divided by the greatest common factor, x minus 7. Remember, it's also like the greatest common divisor. We're dividing it. It cancels out to 1, leaving 3. The 3 goes here. So in this last problem, and I'm just going to erase the division so that we can sort of see what it looked like in the beginning. If we look back at this, we factored out the greatest common factor, which was also a group, and we're left with a binomial times a binomial, okay? Now, as I promised you, there is some extra significance to this last problem, which is why we built into it. This is kind of like a prelude into what's called factoring by grouping, okay? Oftentimes, there will be a 4-term polynomial that happens to have, and it's not the case for this one, but it's something that I cover in a later video, which I'll tell you which one in a second. But basically, sometimes you have a 4-term polynomial in which 2 terms have a common factor and the other 2 terms have a common factor. You factor that out and they become a group. Then they have the same group as in this last problem at the bottom, and then you factor that group out. And then you get the most simplified form, which leaves you with 2 binomial factors. If we were solving this and this were set equal to 0, then we would set this factor equal to 0 and solve for x, and we would set this factor equal to 0 and solve for x. But it's an expression, so we don't have to do that in this problem. Okay. As I was telling you, this last problem is kind of like an intro or a prelude to factoring by grouping. And I cover factoring by grouping in episode 115, in which we start off with factoring a string of 4 terms, as I was explaining a second ago. But then we also do another method that involves factoring trinomials and quadratic equations using what's called the factoring by the AC grouping method. And that uses the factoring by grouping method, plus there's another part that you have to do in the beginning, which I'll explain in episode 117. So that's the end for this video. This covers a few examples of using greatest common factor to simplify expressions or ultimately equations. In the next video, I'm going to go over a few examples with LCD and least common denominator, but then we'll be doing more LCD in future videos as they pertain to the lesson as well. So again, thanks for watching. If you found this video helpful, please give a thumbs up. Please subscribe to the channel. Please share with your friends. Remember, you can find my book, Algebra in Words, on Amazon.com. And I'll see you in the next video.